Hola guys, and what's up? And today this is the continuation for the previous video regarding the remaining theorem. So this is the factor theorem. So maybe you guys are familiar with the word factor. The word factor. So perhaps if you have 6 divided by 2 and you will have the exact value of 3, then we say that 2 is the factor of 6 because 6 is divisible by 2. For example, if you have the general a divided by b is equivalent to the exact value of c, and of course b must be less than or equal to a. Okay, so we say that we could represent this as b divides a, meaning this b can divide a and give the exact value of c, or simply a is divisible by b. So this is the notation. So when we have this, meaning the remainder is 0. We don't have the remainder in this situation. So from the previous video, I have tell you regarding this. Okay, so when we substitute any value or the zeros of the expression, for example h, f of h is equivalent to r, right? But I said here r is 0, so we can have the relationship as f of h. When we substitute h can be anything. Okay, I'm not referring to this. Okay, maybe you guys, this will confuse you. So f of, for example, f of c. So c can be anything, 1 2 3 4 5 6 7. Okay, when we substitute f of c, we will get r equals to 0 or simply 0. Okay, for example, if we have simple question, f of x divided equivalent to 3x minus 5, and you need to verify whether or not it can divide expression. For example, sorry, I don't think this would work, so let me use the higher degree of power as an example, but still you can understand. So if you have f of x, for example, the quadratic function 6x squared plus 13x minus 5, and you need to verify whether or not 3x minus 1 is the factor. So remember, we have this fc is equal to 0, so we need to substitute c. We do not know what kind of c, and will result to 0. So if we find the value of c which results this function to be 0, then it is the factor as our first definition. But we do not know the value of c yet, but here the question asks us to verify whether or not this is the factor. So we assume this is the factor. We assume first. So first of all, we need to find the zeros of this expression. So the zeros is basically 3x minus 1 is equivalent to 0. So we equate to 0 to find the zeros. So we get x equivalent to 1 over 3. Why? Because when you substitute back x equals to 1 over 3 into here, you will get 0, which is the definition for zeros, or zeros. I prefer to pronunciate it as zeros. I don't know why. So we assume that this is the c, and when we substitute inside, will we get the value of 0 or not? Depends. So assume that 1 over 3 is the will resulting into the r equals to 0. So f of 1 over 3 is equivalent to subs here 6 plus 13 minus 5, 1 over 3, 1 over 3, so 6 times, so 1 over 3 squared is 1 over 9, plus 13 over 3 minus 5. Let me get my calculator first. Okay, so we have what? 6 over 9, right? 6 over 9 plus 13 over 3, 13 over 3 minus 5, 0. Okay, so is 0. So then if it is 0, then it is the factor then this f of x is the factor of gx minus 1. Sorry, gx minus 1 is the factor for fx equals to this quadratic equation here, the quadratic function here. Okay, so the question asks us to verify, then yeah, it is the fact, this is the factor of this, so it is being verified already. It is sorry, gx minus 1 is factor of fx simply. So basically for factor theorem is actually the special case for remainder theorem, and the question always asks us to verify or to prove whether or not for example the function of fx has the factor of like gx minus 1 or not, like that. Okay, I think that's all. Thank you.